This is my second hour class, and we're going to be doing some practice problems from the review packet. I am starting with number 9 here, and it's about proving that two things are inverses. So if you had trouble with number 9, pay attention, and I'll show you how this would work. So first of all, if I'm going to prove these are two inverses, I got to find f of g of x. I'm going to put the g into the f function. So this one right here needs to go in there. So it's 3 and then x plus 2 over 3 and then plus 2. And then these 3's cancel, and I'd have x plus 2. Oh, I screwed something up. Where's there a minus 2? Is it that red function there? Should get minus 2. Sorry about that. Okay. And then when I do this, you can tell that it had to be wrong because it wasn't gonna end up canceling, and that's what we want it to do. Now the 3's cancel first because of the order of operations. That's important. Some kids just try to go, everything cancels. It's x. You got to do it one step at a time. How do you do that on the test? I don't know. I can tell you though, the final answer here is x, and then this one's final answer is x. And then I bet you this will work, but I'm going to just do it really fast. F goes into the g function, and so here's the g function with an empty spot. And then I put the f function in there. And then I cancel things in the right order. This would cancel first, and then I have 3x over 3, and the 3's cancel, and it's x. Okay, I proved it. They are inverses. You get that kind? No? All right, good. So that's number 9. Now, it's kind of a dilemma here because I know some of you haven't even looked through the whole packet, so you're not going to know which questions to ask. So those of you that are on the table, please, are fairly on top of this class and can afford to move ahead at a rapid pace, I'd like you to go beyond number 9 with me and see, because I know most of you haven't gone this far yet, but number 10, do you want me to talk over, anybody want me to talk over a mixture problems? 10 is a mixture problem? Okay, 10 is a little bit of a weird mixture problem. All right, I'll help you with that one. So it's got amount 1% 1 plus amount 2% 2 is equal to amount 1 plus amount 2 times the total percent. Now here's the catch on this one. They don't tell you what amount 1 or amount 2 are. They tell you the total is going to be 25 liters. Well, I know to put that here. That's where the 25 goes. And they also tell me the total is going to be 26% acid. Kind of annoying that it's such a close number, but I guess they are different. Well then, and they also tell me the percent of the one kind is 20% solution, and the percent of the other kind is 35% solution. Now the only question is what to put here and what to put here. And I know you know that you can't just put x there, because if you put x in both those spots where the question mark is, you're going to be saying that they have to be exactly equal to each other. That's why I can't just put x and x, because otherwise they'd have to be exactly equal amounts, and we don't know that. So who in here is smart enough? Here you go. X, and then what's the other amount? 25 minus x. Because these two amounts have to add up to 25. Get how x and 25 minus x will add up to 25? X plus 25 minus x. I add that up. This and this cancel. It's 25. So you use x, 25 minus x. From there, it's just a matter of multiplying it out and subtracting, and you can see the answer on the key online, of course, if you really want the answer. Okay? Other ones, like 10 and 11, acid questions. All right. If the mixture problems are in the packet, it's probably on the test. It was last year. You know that much. All right. So number 12. Anybody need help on the vertex? Find the vertex, which is basically complete the square. If you want help on that, I'll be glad to do it for you. That's the one we do half the square. Yeah. You factor out the lead number, like that -2 has to get factored out first and stuff. All right. Number 12A. If you wish to pay attention to this one, if you think you're going to have any trouble with completing the square on the tougher kind. -2x squared plus 8x minus 3, and I'm going to factor out this, because if that's there, I can't do complete the square. So I'm going to factor that out. I'm going to have negative 2 come out. What I have left is x squared minus 4. Let me make sure I have this x, and I'm way up and check myself. I go this times this, and like that, and this times this, like that. And yeah, I did it right. And now I leave a spot for plus a number and minus a number, and the negative 3 just bumps all the way to the end. Now is the time when the little German boy comes in to help out. Half the square. Half of 4 is 2, 2 squared is 4, add 4. And then here's a really important part. People always forget this. They're going to have this answer on the test too, I guarantee it. Some people are going to think that I just go from here and that the last number here is negative 7. That's not right. What am I supposed to do again? That number there has to also go here. Okay, whatever I factored out in front here, because this number has to be timed by this line. So this line has to also get times by that, because those lines are supposed to cancel each other out. Y equals negative 2 parentheses. This is the perfect part. X minus 2, notice it's a minus because there's a minus there, squared. And then this makes negative 2 and negative 4 makes positive 8. 8 minus 3 makes... There you go. Now I should say in the middle of this video that I could make a mistake on any of this. And so just if the key is different than me, just double check. Close. Maybe the key, I could see myself making a mistake. I'm going to do a lot of problems in this review. I don't want you to take it like law. You can always go on Schoology, find the key, and see if I made a mistake. Yes. Good question. I believe there is a calculator and a no calculator part. So I'm pretty sure you are not going to be able to use calculators. Like 95% sure. There's a chance that they did talk about doing some changes at the final. I haven't actually seen it, but they would have probably told me about that. Okay, so we did complete the square. On 13, that 13 and 14 are like those regression questions. We have done those so many times. Wait, 14 is a regression. 13 is like one of those word problem questions. I can help you start setting that up if anybody wants me to. Yes? All right. So on number 13, I would start by making a rectangle. And I know its area is 8,800. So I put that in there, and it says the field is 30 feet longer than it is wide. I don't know how wide it is, but it's 30 feet longer than that. That's what I put here. X plus 30. Now I've got a picture. I've got my picture labeled. I'm really close. I just need to have an equation of some sort. Well, what's the equation I would need? I have got all my information in here already. I pretty much just need to do an area formula. Area is length times width. Area is 8,800. Length is this, and width is this, or vice versa. So you just put these in here. And then, how would I finish? I graph both sides and see where they cross. That's a really powerful way to finish. Anytime you want an answer to an equation, just think of it that way. Any equation on the ACT, the SAT, you want the answer to it, just graph it. Now, if this one happened to be on the no calculator part, if this was on the no calculator part, I'd have to multiply it all the way out, and it would be a giant quadratic. I'd move this 8,800 over to that side, I'd multiply this all out, and I'd have 0 equals x squared plus 30x minus 8,800, and I would hope that that would factor. Because otherwise, and it probably would, people write the tests like factoring, so if it was on the part where there's no calcs, it probably factors. Right? All right, 14 is regression. We've done it bazillions of times. 15, my advice there would be to just get the 7 over to the other side and then square both sides. Number 16 says find the y-intercept. The y-intercept is where x equals 0. Above number 16, why don't you just write set x equals 0. Give yourself a little advice as you are going through this. Number 17, that's the kind where it's piecewise functions. That's where you graph. If I were you, I would graph all 3 of them on your paper and then just kind of erase the parts that you don't need. Like for instance, let's say you graph it, part of it's this, and part of it's a straight line that has a slope of like 3 or 2 or something like that. Maybe that's actually, that looks like more like a slope of 1/2 or something. And then the other function, let's say it's a straight line going like this. And then how do you know what the final answer is? It might only be the green line up until it hits 0. And then from the green line, it progresses to being the black line in this little part of the graph. From 0 to 2 or something. So you'd say, and then the last thing, maybe it's the blue line from there over. So they end up being a little bit of this empty spot, and then you start over again here, filled in circle, and then maybe it's an empty spot here and a filled in circle here. That's kind of what a piecewise looks like at the end. Graph all 3 of them. You want to actually do one of them? Which one? 17A or B? All right. Okay, which one of the equations is the one that you don't recognize? The x squared part, or the 1 part, or the negative 3 minus x part? All right. If I have to graph this, there's 3 parts to it. There's negative 3 minus x, and then there's y equals 1, and then there's y equals x squared. Do you get that be a parabola? Do you get that would be just a straight line? This one's also a straight line, but it's a little weirder. So I'll graph all 3 of them quick. This one's just a parabola. This one's a straight line at 1. And the last one, the top one there, is negative 3 minus x. It's like this, negative x minus 3. I'm just rearranging it so I can say the slope is negative 1 and the y-intercept is negative 3. So I'm going to start right there, and the slope of negative 1. So it's like a line that runs like this. Do you know I got all 3 lines? This one here, right here, just that one right there. Okay, then how do I know where they are, those things? It's only this one when x is less than or equal to 0. So that means that from here to the left, that's where it's less than or equal to 0. It's got to be this line right here. So it's got to be the black one. Right, so I'm going to undo the last couple things I've written on the board here. And now I'm going to delete small eraser. Delete out stuff. It's multiple choice. So do which pictures. So then the next one is it's y equals 1 between 0 and 1. So that means like between here and here, it's this one. So, and it's in degree. And then the last part is where it's x squared, and that's only the red one. So there is and the endpoints are really important. This one was less than or equal to 0, so it's filled in dot. This one where it was 1 is not filled in because they're not or equal to. Empty spot. And then the last one's pretty tricky. How do you get a filled in spot inside an empty spot? Let's do something like that. All right. So there is a piecewise function. There's a lot of stuff to cover. We got to keep moving. Because the equation is x squared, do you agree that at 1, when I put in a 1 here, the answer to it will be 1. So it touches at 1 comma. The graph looks like this. It starts here and it swings up that way. All right. Okay. So number 18 is a function, just generally what do those functions look like? At absolute values, those are V-shaped functions, except those have just been moved and stretched and flipped. In general, that seems like the things you guys are the best at. Just don't forget, this is the most common mistake I see, is kids just brain fart and think, oh, that's 3 times wider. It's actually what? And third is wide. Good. 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 Yep. All right, so the next one is number 21 I'm being asked about. Oh, wait, before we get there, number 20, I do know there's like a zillion people that screw up 20E. Just look at 20E for a second. Everybody, just look at 20E for a second, and then if you already know that kind, you can skip it. Remember how you do the F of absolute value of X versus the letter F, which is, I'm up to, you know what, if I just keep doing them in order and I never go backwards, I don't need to keep track of which problems I've done. Just, we're not going to go back past number 20. So number 20, E is this and F is this. And I put the absolute values around the whole thing. Okay. Well, what's the difference? This is the kind where your little shape, where in this case, your little shape is like a, it's called a sawtooth function. It goes like that, basically. If I do this to it, the x's are getting absolute valued. The x's are these numbers. The absolute value would make the negative ones turn positive. Remember how this one, you wipe out this part right here? Because that's where all the x's would have been negative. Remember that? All right, so then all that part gets wiped out. I'm going to use my surgical eraser here. Out that part. And now, how do I finish the graph then? I just reflect the stuff from the other side over here. So I go up, and down. I'm trying to reflect that other side. So this should be a mirror image across the side. That's how that kind works. How about the ones like this? They take all the y's, the f of x is like y, they take all the y values and wipe them out. So I'm going to go back, find out what this looked like before I did that. There we go. Oh, and now all the y values being absolute valued, means I take out all the stuff that's down here, like the stuff that's underneath the line. That's where y is negative. And that stuff's going to get positivized. And so I'm going to reflect it back up like this, up like that, and then surgically erase this part of it. That's how those come. Okay, now I was asked about 21. Whenever they say, I really don't like this way of saying it, but they do use this a lot. Consider the collection of all rectangles that have length 1 less than 3 their width. That should be 3 times their width, first of all. So in number 21, if you could insert that word after the word 3, say times, 3 times their width. What they want then is a rectangle so that this is just the width and this is 3 times the width, except what we had first. So is 1 less than 3 times their width. Okay, and then it says the areas are greater than or equal to 1,000. This is not just equal to 1,000. It's got to be bigger than or equal to 1,000. So then when I'm doing this out, I say area is length times width. Area is 1,000, but I shouldn't just say equal. Okay, the area has got to be equal than or greater than or equal to. Well, this is kind of tricky. These numbers are easy, 3x minus 1 and x, but what sign do I put in there? I want this part to be bigger than or equal to 1,000. This part has to be bigger than 1,000. This one already is 1,000. So I actually have to put it like this. So that this part, if I had written it the other way, 3x minus 1 and the x here, I could say it's bigger than or equal to 1,000. It would read better. But if I write it this way, of course, it has to go backwards. Okay, so the pointy end has got to be pointing to 1,000. All right, and how would you finish it from there? If it was a graphing test, graph both sides, see what it drops. I hope that really gets burned into your head so when you hit the ACT and SAT test, to give you these kind of equations. They should be a no-brainer. Just graph it, see where they cross. If it's not a graphing part, you'd have to put it all onto one side, make it a giant quadratic, and then hopefully it factors. If it doesn't factor, you have to use quadratic. All right, we're nowhere near done with this puppy. So is there any, I'm going to give a pause now for a moment and let you just process. I want you to flip through this next part of the test. And I can't do every problem. If you recognize a problem and you're like, oh, I'm so close on this one, I could really use some help, I'll be glad to show you a few more. So I'm going to pause for a minute. You decide which of the next few problems you might want to see. And I'll be back after about a minute and a half plus. Okay, we're back and we're doing number 23. All right. So when is one part of a graph bigger than another part of a graph? Let's say here's my two graphs. Let's say this is f of x, and this is g of x. So maybe I could make them different colors by making this one blue. Do you get when the one graph is higher than the other graph, then that means that it's bigger? Can you see that that the g of x graph in this little zone right here is bigger than the other graph? So it would be, g of x would be bigger than f of x between here and here. That's what they're talking about. Does that help you? Should I actually do this question? Okay, read me that. How about this? I need to grab your packet book to be able to see. Thank you. It looks like basically like that. Line like that. Touches at negative 3, 5, and 2, 2. Thank you. And they want to know when's P bigger than Q. And this one's Q, and this one's P. When's P bigger than Q? P is bigger than Q in this little zone right there, because it's higher above the other one. The other one's down here. All its points are lower. So it's bigger in that little zone from here to here. So what's that from? From what to what? From negative 3 to 2, because these are x numbers we're talking about. When I say from here to here, I'm talking x numbers. So that's negative 3 to 2. And you could probably argue about whether it's parentheses or brackets. It could be either one. So if one graph is higher than the other one, it's great to read. All right. Now number 26. So read me 26. Okay. If a function's inverse is a function. All right, read me the functions. Okay. And I want to know if that function has an inverse, which is also a function. Well, first of all, I got to know what the picture looks like. So first of all, it's a butterfly shape because the base of it is 1 over x. So it basically looks kind of like this, except it's been moved 4 to the left, and it's been stretched, which you'd never even be able to tell. So I'm not going to worry about stretching. All right, so basically it looks like that. Now the question is, does its inverse have a function? Do you remember the vertical line test? That tells you if something's a function or not. So this is the vertical line test. I'm going to draw a fuchsia colored line. Here we go. And is this a function? Yeah, it's a function because it never fails the vertical line test. It only touches once. I can only do like this. Now, if it also passes the horizontal line test, another line in green, let's say, like this, if it can also pass that test, which, by the way, this one does pass, then it's one of those special functions that is a one-to-one function. And its inverse will also be a function. So this just tells me, is it a function? This tells me, is its inverse a function? And if it passes, which it does, it only touches once, then this is a one-to-one function. And therefore, this one does pass, and therefore this one does have an inverse that is a function. So 26 is a one-to-one function. Yes. You don't have to prove it. You just have to say it's a multiple choice test, remember. So you'd be able to sketch it quick and look at it for yourself and see, does it pass or not? There's a lot of functions that don't pass. Like any parabola, you can see it's a function, but it won't pass this test. Touches twice, so it's not a one-to-one function. It would not be its inverse would not be. All right, moving on. Is there any other things past number 26 you want to ask questions about? We're getting down in time. All right. What I'm going to do, I know there's more questions that could be asked. I know you guys are kind of burned out. That's why you probably stopped asking questions. So, if you come up with more questions that you're like, I don't know how to do this, make sure you check the key. And then if you still need help, I'll be here in the morning, tomorrow, 8 to 10. That's plenty of time. You got 2 hours in there. Come in and ask me questions tomorrow morning, 8 to 10. Last thing is, I'm going to try, I think this would be smart. I'm going to try to take my next hour and have them ask me questions from the second part of the packet. Get what I'm saying? Because if they ask me questions from like 27 to 40 or whatever, then if you wanted to, you could watch the video for that. Okay? So I'll try to focus them in on that second half of the packet for my next video of the day. All right?